Identifying zeros and their multiplicities. Graphs behave differently at various x-intercepts. Sometimes the graph will cross over the horizontal axis at an intercept. Other times the graph will touch the horizontal axis and bounce off. So suppose, for example, we graph the function shown f of x, which is equal to x plus 3 times x minus 2 squared times x plus 1 cubed. Now notice in the figure 7 that the behavior of the function at each of the x-intercept is different. Okay, so let's take a look at this first x-intercept. Okay, the first x-intercept is x plus 3, which would be x equals negative 3. So therefore, you can see that this one goes right through the x-axis. Okay, and then the next intercept is x minus 2, and you can see that it's squared. Okay, which means what we would say is that this has a multiplicity of 2. Meaning that if you would solve x minus 2 squared, that means you have 2 solutions. So what I mean by that is, let's go ahead and write that out. Okay, we have x minus 2 squared, which is equal to 0, is the same thing as x minus 2 times x minus 2 equals 0. That means we have x equals 2. That means we have a multiplicity of 2, because there's 2 solutions at 2. So I want you to look at this intercept. So here at 2, what happens here is that it touches 2 and then it bounces off. Okay, and that's where it says on the graph it will touch the horizontal axis and then bounce off. Okay, now let's take a look at the next one here. So the next one we have x plus 1 cubed. If we set that equal to 0, that means we have x plus 1 times x plus 1 times x plus 1 equals 0. Which means when we solve this, we're going to get negative 1 3 times. So that means that we have a multiplicity of 3 for negative 1. So what happens here, and I want you to look at the x-intercept, is that when we look at the x-intercept, okay, what it does is, because it has a multiplicity of 3, it flattens out at the x-intercepts and then it goes back up. So there's 3 different scenarios here. When we have a multiplicity of 1, it just goes right through the x-axis. When it has a multiplicity of 2, we can see that it bounces off that x-axis, or where that x-intercept is. And when it had a multiplicity of 3, what it did is it got to the x-intercept, it flattened out, and then now it's going back up. So let's look at each of these individually. Okay, so we can see here that we have the first x-intercept at negative 3. Okay, the first x-intercept, x equals negative 3, is the solution of equation x plus 3 equals 0. The graph, again, passes directly through the x-intercept at x equals negative 3. The factor is linear, which has a degree of 1, so the behavior near the intercept is like that of a line. It passes directly through the intercept, and we call this a single 0 because the 0 corresponds to a single factor of the function. Now, if we take a look at the next x-intercept, which is positive 2, so the x-intercept x equals 2, it is a repeated solution of the equation. We had x minus 2 to the second power, which is equal to 0. The graph touches the x-axis at the intercept and then changes direction. The factor is quadratic, which is a degree of 2, so the behavior near the intercept is like that of a quadratic. It bounces off the horizontal axis at the intercept. So we have x minus 2 squared, which is the same thing as x minus 2 times x minus 2. So because the factor is repeated, the factor x minus 2 appears twice. The number of times a given factor appears in a factored form of the equation of a polynomial is called the multiplicity. The 0 associated with this factor x equals 2 has multiplicity 2 because the factor x minus 2 occurs twice. Now, the x-intercept, x is equal to -1, is the repeated solution of the factor x plus 1 to the third power, which is equal to 0. The graph passes through the axis at the intercept, but flattens out a bit at first. This factor is a cubic, a degree of 3, so the behavior near the intercept is like that of a cubic with the same S-shape near the intercept as a toolkit function f of x equals x cubed. We call this a triple zero or a zero with multiplicity 3. So for zeros with even multiplicities, the graphs touch or are tangent to the x-axis. For zeros with odd multiplicities, the graph cross or intersect the x-axis. So taking a look at figure 8, we can see examples of graphs of polynomial functions with multiplicity of 1, 2, and 3. So here we can see that it's passing through with a multiplicity of 1. Over here, it's bouncing off the x-axis. So this is a 0 with a multiplicity of 2. And over here, you can see here that this flattens out at the next intercept and goes through the x-axis. So we have a 0 with multiplicity 3. Now, for even higher even powers, such as 4, 6, and 8, the graph will still touch and bounce off the horizontal axis, but for increasing even power, the graph will appear flatter as it approaches and leaves the x-axis. And then for higher odd powers, such as 5, 7, and 9, the graph will still cross through the horizontal axis, but for each increasing odd power, the graph will appear flatter as it approaches and leaves the x-axis.